Hi, okay, here's the final video for lesson 2, and it's about division of polynomials. We've already talked about adding, subtracting, multiplying, so last but not least is division. So there are two different types of dividing polynomials, long division and synthetic division. I'm going to go through both the processes right now, and then you're going to be able to practice them later on. So let's take a look at the first slide here, which is long division of polynomials. This is what we're going to do. We're going to divide p of x, x cubed plus 5x squared plus 6x plus 9, by d of x, which is x plus 3. Really important that we remember whatever we're dividing it by is the divisor, and what I'm breaking up is the dividend. So if we take a look at my setup here, it's going to look like this, where my dividend is under my division bar and my divisor is outside of my division bar. What goes up top is my quotient, which really, if I'm starting this from the very beginning, there's nothing up top. But as I go through and solve the problem, that's where I write numbers above the division bar in my quotient. So I'm going to start this, and on the side of my paper, I would write x times what is going to give me x cubed. Okay, and I want to think about this multiplication, and what we're going to get is x squared. So then I write that number on top of my quotient. Once we put a number in the quotient, I go ahead and then multiply it by both of my divisors. So x squared times x gives me x cubed, x squared times 3 gives me 3x squared. Parentheses subtract. Why it's really important to put parentheses is because I need to remember to subtract x cubed minus x cubed and 5x squared minus 3x squared to give me a positive 2x squared. Once we subtract, just like when we divide rational numbers, I need to bring down. So now I bring down the 6x, and on the side of my paper I would start over, just like I wrote that on the side before, and I would write x times what is going to give me 2x squared. It's always those first numbers in the front. That's where I get the 2x, so notice I have that next number in my quotient, and again we distribute it. So 2x times x gives me 2x squared, 2x times 3 gives me 6x. Same thing. Parentheses subtract, and I get 0. I bring down my last term, which is 9. If there's nothing else for me to go into, like I can't do this. I can't do x times blank to give me 9. Doesn't work. So once I'm done, there's my remainder. Here is how we want to write our final answer. And the setup goes as follows. I have to do the quotient, which is what's above my division bar, x squared plus 2x, plus my remainder, which is 9, over my divisor, which is x plus 3. Okay, this is the same process that we're going to use the whole time to divide polynomials using long division. The second method is a little bit shorter, way shorter actually, and it's called synthetic division. Okay, synthetic division of polynomials has to specify, okay, I want to check you using synthetic division. Synthetic division only works if your divisor is in the form x plus a or minus, x plus or minus a. And your a term is that number after the x. Okay, so for an example for this one, my a would equal 3. It's always the opposite sign. So this is x minus 3. My a is a positive 3. When I go and set my synthetic division up, like I said, it's really weird. Let me actually show you what it would look like without all these numbers in there. So what you have to do is first you want to rewrite the division problem with just the numbers. So I put my a value up front, and then I take my coefficients of each term. 2 gets written down, negative 7 gets written down. I need a 0 placeholder when a variable is missing. The x term is missing, so I put a 0 placeholder, and then I write the constant negative 4. From there, what I do is it involves our two favorite operations, multiplication and addition. So then I always bring down the first number, so my first number is a 2. From there, I multiply. So I take 3 times 2, 3 times 2 is going to give me 6. And then we add straight down. Negative 7 plus 6 gives me negative 1. Okay, then I'll go again. 3 times negative 1 gives me negative 3. Add straight down. 0 plus negative 3, negative 3. 3 times negative 3 gives me negative 9. Add straight down gives me negative 13. And that's it. I would go through that process a few times. Bring down, multiply, add, multiply, add, multiply, add. It's tricky because in the very beginning we took out those variables, right? Notice I have these random numbers written. But now by the time we get to the end, I have to put those variables back in. I always want to start at the very last term. The very last term is my remainder. If this is a 0, then I have no remainder. My remainder is negative 13. In standard form, I'll then have a constant, then an x term, and then an x squared. If I need more, I'll go x cubed, x to the 4th, and then I put it together. So now this will read, over here, my quotient is at the bottom. 2x squared minus 1x minus 3 plus my remainder, negative 13, over my divisor, x minus 3. Goes back to our original problem for the divisor. Okay? Awesome job, guys. Thanks so much for watching how to do long division and synthetic division of polynomials.